with one of my favorite 3D shapes because it holds ice cream. Who wouldn't love that? Anyway, we're going to do a new shape, which is the cone, and we're going to talk about how much stuff fits in a cone. So we're going to be calculating volume. Now, normally, if we were in class, I'd be doing this demonstration of showing you how a cone and a cylinder relate. And I'd be using my plastic shapes, and I'd actually be using some rice. Can't do that here, so I did find one online. So let's take a look at this comparison of the volume of a cone to a volume of a cylinder. Just give me 1 second, and I'll get out there so we can watch it.
In this video, we'll demonstrate the ratio of a volume of a cone and a volume of a cylinder. We have a cone and a cylinder with the same diameter and height. The cylinder is filled exactly with 3 full cones of water. The volume of the cone is 1/3 of the volume of the cylinder.
She did a lot better job than I do with the rice, in that I don't think the woman spilled a single drop. I usually have rice all over the floor. But what you should have just noticed is that the cone will fill up the cylinder 3 times. So the cylinder has 3 times the volume of the cone. And if we reverse that thinking, the cone has 1/3 of the volume of the cylinder. So if we know the formula for a volume of a cylinder, which we just talked about, the only thing we have to do to get a cone is to divide it by 3. That's the same thing as multiplying it by 1/3. You're going to see me using the dividing by 3 idea because it works better in your calculator. So again, just to show you a picture here, here is the cylinder. Remember, we take the volume equals the base area, the area of the circle, pi r squared, times the height. The cone is going to be the area of the base, the area of the circle, pi r squared, times the height, but we're going to take 1/3 of it. We're going to divide by 3. This idea we already kind of talked about when we compared the pyramid to the cube and realized that the square pyramid has 1/3 the volume of the cube. So it's the same idea that where that shape comes into a peak, so in the pyramid it comes to that top vertex point, all this other volume is missing. It's taken away. So 1/3 of the volume is inside the pyramid or the cone, and 2/3 of the volume would be outside of it. So today, let's take a look at what we just discovered. And you're going to notice now, I know that you guys don't have your books, so notes pages and any homework assignments out of the book, I will be scanning the pages and attaching them to Classroom. So I know you don't have your book, but a cone is a 3-dimensional figure that has one circular base, unlike the cylinder that had 2. It has one circular base, and it's connected to a single vertex at the top. It has that sharp point. Now you're going to notice they're talking about the volume being 1/3 the base area times the height. Remember that the base area, the capital B, is a circle, so the area of a circle is pi r squared. So this is the formula the book's using. I am just going to change that slightly. Instead of multiplying by 1/3, that's the same operation as dividing by 3, and this is the easier way to do it in the calculator. And that's kind of what I'm showing you down here. Here are the buttons on the calculator that you would use. So you would put in your radius. What is the distance from a point on the edge of the cone to the center of the base? That's the radius. And you would square it. You'd hit the x squared button. you'd multiply it by the height. How tall is the cone running from the vertex to the center of the base? That would be the height. And then we're going to divide it by 3, and then you hit enter. Now, if you were to stop right there, that number would be your exact answer with a pi written after it. Once you hit times pi, you're going to be approximating the volume of the cone. So let's take a look at an example. So here's an example of a cone. It has a radius of 3. Notice it only goes from the center to a point on the edge of the cone. It's not the diameter, it's the radius. And then the height is 6. So we're going to take, just like we did for the cylinder, we're going to take the radius squared times the height times pi, but we're going to divide it by 3 because it's a cone. 3 squared is 9. 9 times 6 is 54. 54 divided by 3 is 18. I haven't multiplied by pi yet. This is considered my exact answer. The minute I take my calculator and take 18 times pi, I'm giving an approximate volume and estimate, and it's about 56.5 inches cubed. And we will be rounding to a tenth. That means you leave one decimal place on your answer, and you only look one place past that number when you're rounding. Here are the steps. You would have taken 3, hit the squared button, times 6, divide it by 3, and hit enter, and 18 would show up on the calculator. Once you hit times pi, you should see the 56 point, and again, we're rounding to 5. Our units for volume, again, are cubic, 3 dimensions, inches cubed. Make sure you always put your units, and for volume, make sure they have a 3 as an exponent. Let's take a look at another example. A cone-shaped paper, so cup. So you see I'm kind of making sure I know it's a cone and not a cylinder, so I'm underlining that as I read through my problem. It's filled with water. The height is 10 centimeters. So from that sharp point down to the center of the base is 10 centimeters. And this time the diameter, now the diameter is going to be the entire distance across the base running through the center, and that's 8 centimeters. We don't use the diameter in our formula to find the volume for a cone, so I'm going to cut that in half. Half the diameter is the radius, and that's where this 4 is coming from. Radius squared times height divided by 3. So 16 times 10 is 160. Divided by 3 is 53.3 repeating. And I'm going to put the bar there and stop. Put the pi on. That's my exact answer. Need the bar on there to know that it is your exact answer. And I'm going to leave that 53.33333 in the calculator, multiply it by pi, and now that's approximately equal to 167.6 centimeters cubed. Here are the steps in the calculator again if you need them. I'm going to move on. We're going to just do 2 more examples, and then I think you'll be ready to give it a go on your own. So what I'd like you to do is to pause the video right now and try to find the volume of both of these cones. And in a second, we will come back and see how you did. Okay, everybody, let's take a look. They gave us the radius here, the diameter there. So this one's going to be the easier one because we have what we need. So the radius is 2 feet. The height is 7. So here is my formula. Again, I wanted to just mention that you will see the formula in most textbooks is 1/3, but that is the same thing as dividing by 3. So 1/3 pi times the radius squared times the height. Now I'm going to get out here and I'm going to take the 2 squared, which is 4. I'm going to multiply it by the 7, and I'm going to divide it by 3. And you should see 9.333333 in the calculator. I'm going to put my bar notation with my pi, and that's called my exact answer. I have not approximated, and I haven't multiplied by pi yet. Now, the minute I take that 9.33333 and multiply it by pi, then I will have my approximate volume. It's about 29.3. Don't forget your units of feet, and since it's volume, it should be a 3. Area is squarea, and straight units, like measuring your height, would be an exponent of 1. But when you're finding volume, you need to have a 3 up there. Okay, let's take a look over here. Notice that the first thing I did was take that 24 and divide it by 2. I cut it in half because I've got the long guy and I need the short guy. So you take the diameter divided by 2, there's your radius. Again, here is the formula as written in the book. 1/3 pi times the radius squared times the height. I'm going to take that 12 and square it, multiply it by 26, and divide by 3. And I will see in the calculator 1,248. And if I write a pi after that, that's my exact answer. Take the 1,248 times pi, and it's approximately 3,920.7 millimeters cubed. So again, there is our volume formula that you'll mostly see out in the real world. That's how it's written. But please remember that that is the same thing as dividing by 3, and this is the easier way to do it in the calculator. Well, I hope that that helps get you started on finding the volume of a cone. It's directly related to our cylinder. It's the exact same formula as our cylinder, pi r squared h, but we just divide it by 3 to get the volume of a cone. So let's start off with this first problem where April is filling 6 identical cones. You're going to notice I circled the 6 and underlined the cones. I don't want to forget that we're actually going to have 6 at the end, not just one cone. And I'm also underlining cones because as we go forward, we've always got to keep our eye on what shape are we working with because we now have cylinders and cones. Each cone has a radius in this problem of 1.5 inches. I've underlined that. And the height is going to be 9 inches. So notice by kind of just doing that little bit of underlining, I have all the information I need to move forward. What is the total volume of the cones? That's all 6, and we're going to round to the nearest tenth. We're going to remember that our volume formula is really found from taking our cylinder formula and dividing it by 3. So our cylinder formula was pi r squared. That's the area of the circle of the base times the height of the cylinder. And then if we divide it by 3, we get the volume of a cone. So in this particular case, the radius of 1.5 is going to substitute in for r, 1.5 squared. The 9 is going to take the h spot. And we're going to calculate the volume of one of the cones. So there's my radius, there's my height, and there's my substitution. The 1.5 squared gives me 2.25. I multiply it by 9 and divide by 3, and you should see 6.75 pi. This is called the exact answer. We haven't approximated and we haven't multiplied by pi yet, so that would be precise. And the minute we pick up our calculator and take 6.75 times the pi button, you're going to see 21.2 inches cubed for one cone. Now I need to remember what I circled up here is that she's actually filling 6. So we need to take that volume for 1, multiply it by the 6 cones, and when we take 21.2 times 6, we'll have 127.2 inches cubed. Now let's put some shapes together. It's called a composite. So if you look at this shape here, sometimes it's hard to see. So let me use this screen so you can see that on top of this kind of odd shape is a cylinder. The cylinder has a diameter all the way across the circle base of 8 feet, and the height of the cylinder is 4 feet. To find the volume of just that piece of this shape, I need to take pi times the radius squared. So I'm not going to put 8 in for r. I'm going to cut it in half. My radius is 4, and you'll see pi times r squared, 4 squared, and this other 4 is the height. So pi r squared times 4 will give me the volume of the cylinder. 4 squared is 16, and 16 times 4 would be 64 pi, and that would be the exact answer for the cylinder. You'll see it right over here. And if I take 64 times pi, it's about 201.1. Now I need to caution you that our book often uses 3.14 as an approximation for pi. So if you use the pi button, you might be slightly off, but the pi button is actually the more accurate way to go. Now that's the cylinder. Now if I look at the bottom, let me just put the screen up there. Can you see that cone that's on the bottom? Okay, so now we're going to find the volume of that cone. The cone has the same diameter that the cylinder did. So again, we're going to be using a radius of 4. But this time, the height of the cone is a little bit bigger. It's 5 feet. So we're going to take pi r squared times 5, but we're not going to stop there because it is a cone. We have to divide it by 3, and again, the book likes to show multiplying by 1/3. When you multiply by 1/3 or divide by 3, that's the same operation. So I square the 4, 16, I multiply by 5, and divide it by 3, and that would be 26.6 repeating in the calculator. And 26.6 repeating pi would be your exact answer for the volume of the cone on the bottom. I could add those two together and get a combined exact volume of 90.6 repeating pi. Or down here, just like we did up above, I can take that 26.6 repeating, multiply it by pi, and notice it's about 83.8. Now, if I add the 201.1 cubic feet from the cylinder with the 83.8 cubic feet from the cone, this odd kind of looking shape over here could hold 284.9 cubic feet. That would be the volume. Okay, let's just do one more. And if you look at this shape, I hope you can see there are two cones in there. One is pointing to the left and one is pointing to the right. I have added these little dotted lines to show you some of the things going on. So if you look at the, I'm going to just trace that left cone there, okay? He's actually laying down. He's fallen over on his back. His height is actually this blue dotted, which is the 5.5. And this red dotted is representing the radius of the base circle. Now the right-hand cone is also laying down. He's quite a bit taller at 13 inches, and he has the same radius on his base circle of 6 inches. What we need to do is calculate those two volumes, the left and the right, and then add them together. So I'm going to give you a second to do that, so please pause the video and give it a try. Okay, guys, let's see how you did. Remember, this is our volume formula. We're going to take pi times the radius squared times the height of the left-hand cone, divide it by 3. And we're going to do the same thing with the right-hand cone. And when we're done, we're going to add them together because these two cones are stuck together. So we're going to add their volume. So the left-hand cone has a radius of 6 and a height of 5.5. So I'm going to square the 6, multiply it by 5.5, divide by 3, and that would give me 66 pi. 66 pi inches cubed. That's your exact answer. Now 66 times pi would be about 207.3. Our units are going to come in a second. I have not forgotten them. Now we're going to do the right-hand cone. His radius is still that 6 inches, but the height is longer at 13 inches. Here is my substitution into the formula for volume. The 6 was the radius, so r squared. The h is 13, and we're going to divide by 3, and you're going to see an exact answer of 156 pi. I'm going to multiply pi and get an approximate answer of 490.1 inches cubed, and I'm going to add these two together. Now, if I add the two exact answers together, I would get an exact answer of 222 pi. And if I needed to do an approximate and I add the 207 and the 490 with their decimals, it works out to be about 697.4 inches cubed. So composites really aren't that tough. It's really just kind of like doing two problems in one and either adding or subtracting at the end. Both of the problems we did today are adding, but if you have a hole in the shape like we did with the cylinders, then it would be subtracting.